All right. So now the next session here, we are going back in time to structured programming. And it's going to be Martin Doherty talking about Apple Pascal and introduction. He's going to tell us about Apple's fourth major programming language and tell us the hows and whys to get it running here in 2025. So take it away, Martin.
Okay, so this is an introduction to Apple Pascal. I want to tell the story of this development language and environment that was relatively important in the Apple II world for quite a number of years, probably at least 6 or 7 years. It was pretty big, and then it just kind of sank almost without a trace. So I wanted to go over how it came to be, where its roots were, what happened with it in the Apple world, and why you might want to mess around with it in 2025. So a couple of graphics here. There's the famous Pascal syntax poster, which I'll come back to in a little bit. And the second one is actually a bit of marketing that Apple did when they released the language system to begin with. They did a double-page magazine spread, and they included an iron-on transfer. So I've flipped it around here so that it looks like how it looks on the T-shirt when you wear it, but it was the mirror image of that, and you would rip it out of the magazine page and you would iron it onto your T-shirt, so that was a pretty cool little marketing trick. Okay, let's go back in time. The very beginning, at the start. This gentleman in the corner was a Swiss professor at the Federal Institute of Technology in Zurich, a very distinguished computer scientist by the name of Nicholas Wirth. He actually only just died early last year at the age of 89. He worked in the 1960s on Algol. He was on the Algol 68 committee, and he didn't like the way things were going. So he left the committee and he struck out on his own. He designed a lightweight teaching language. He wanted to be able to teach these new structured programming techniques to students, and he felt that the existing languages were not really suitable. So he came up with Pascal. He named it after the French philosopher and mathematician Blaise Pascal. And the very first system was a Control Data 6000 mainframe, but it spread around. It was in the early years, around late 1969 to 1972 or so and beyond. Academia was sharing this Pascal compiler, and people were porting it to new systems. They made it a portable architecture. The compiler was written in Pascal itself. So it made it very easy to transfer onto many platforms. He's also famous for a few other languages. You may have heard of Modular 2, for example, and Oberon was I think his last major effort. Now there's there's an implementation of Pascal, which was developed by a team at the University of California, San Diego, led by Professor Ken Bowles, and that's him there in the corner. He was the project leader. He also wrote a book, The Beginner's Guide for the UCSD Pascal System. Ken passed away about 7 years ago. So about the mid-70s, he was looking for something to help teach programming to students. And with these smaller machines that were becoming available, he wanted to set up an interactive Pascal environment to run on those small machines. So he designed a system that was based on a subset of Nicholas Wirth's Pascal, very portable, almost machine independent. So it's based on what he called a P machine. So it's a virtual machine definition. It executes P code, and then you emulate that machine on your target platform. So very similar to the Java bytecode approach, actually. You just have to interpret the P codes to your Z80 or your 8086 or whatever your native chip is. It went through versions 1, 2, 3, and 4. some of the platforms it was implemented on: PDP-11, the Terac, the Sage, HP, BBC, Commodore, Apple, TI, IBM, and there was the Western Digital Micro Engine, which was actually a hardware implementation of the P machine. So it couldn't do anything else but run UCSD Pascal programs. Okay, how did this system make its way to Apple? Well, that guy up in the corner, that's the employee badge of Bill Atkinson, employee number 51 at Apple Computer. And a lot of you will have, if not everyone, will have heard of Bill Atkinson, very notable, pivotal staff member at Apple over many years. And he just passed away in May of this year. And so there's a lot of publicity around that just recently. But from folklore.org, I didn't realize that Bill was the guy who brought UCSD Pascal and turned it into Apple Pascal. So in Bill's words, he said, I wanted to port the UCSD Pascal system to the Apple II. We needed to build software in a cumulative fashion with libraries of reusable modules. Apple Basic didn't even have local variables. Manager said no, but I went over his head to Steve. He had a pretty good relationship with Steve. They used to walk around the lake and exchange crazy ideas. Steve was like, yeah, I think basic and machine language is fine, but I was so passionate about it, he gave me 2 weeks. I boarded a plane to San Diego, worked like crazy for 2 weeks, and returned with a working UCSD Pascal system running on an Apple II. He says they ended up using it to bootstrap the Lisa development, but he completely skipped over the 5 or 6 years where it was a major development platform itself within Apple. Now, it sounds like he went to San Diego by himself and did all this work. So I want to give you a bit of a different perspective from somebody else. This is a note from Richard Gleaves. Richard and Mark were students at UCSD. And Richard wrote, I hope it's not too forward of me to humbly request that my name and Mark Allen's be added to the list of original UCSD Pascal developers. Mark and I spent the summer of '78 working at UCSD writing the 6502 interpreter that later became the basis for Apple Pascal. We were being paid junior coder wage, $5.50 an hour. The interpreter was actually developed on a Rockwell 6502 box. At the end of the summer, Bill Atkinson shows up and worked closely with Mark to get it running on an Apple II. Later, Bill offered Mark and me jobs up in Cupertino, but we both turned him down because we both wanted to stay in San Diego. Interesting trivia, Mark Allen went on to become a well-known Apple II developer. He wrote Stellar Invaders, Pest Patrol, and I've got a screenshot from Sabotage. I'm sure everyone's familiar with that classic game. So now we have Apple Pascal. It was really managed and led by Bill Atkinson, Jeff Raskin, with the blessing of Steve Jobs. There's the boot screen in the corner, so you can see it's it's kind of it looks like a green screen mainframe type application, and those are its roots. The roots keep showing when you use the software. So it's based on the second version of UCSD. They basically forked it from 2.1, and then they started their own numbering scheme. So 1.0 of Apple Pascal came out in 1979, about the middle of the year, not long after DOS 3.2. So it was originally a 13-sector software. And then it wasn't very good either. It had some pretty big problems. 1.1 came out pretty quickly. And 1.2 a few years later, because the 2E and the 2C had come out. So 1.2 added support for 128K, and boy, did that make a difference to the usability of the system. And the final version was 1.3, came out in 1985. Beautiful version of Pascal, lots of enhancements, wonderful documentation, just in time for Apple Pascal to basically, sing its swan song and sink into the sunset, because it rapidly lost importance after that. It was used very closely as a basis for Pascal on the Apple III on the SOS operating system. And as Bill Atkinson mentioned, it did become part of the bootstrap that led to Lisa Pascal. So this, if you haven't seen it outside of Apple, it was pretty much everywhere inside Apple for quite a few years. Here's some Apple software that was built with Apple Pascal. I didn't realize this. The DOS 3.3 basics disk that you put in and boot, it's very quick to boot. It's actually a stripped down Pascal runtime. The Apple Presents series, the Apple at Work, an introduction to the 2E. You can see on the label, Pascal operating system, Pascal based, 80 column. And of course, outside of Apple Computer, TADA, Wizardry, the very, very famous and amazing role-playing game for the Apple II, built all in Apple Pascal. Well, probably not all. I'm sure there was some 6502 in there, but the bulk of it was written in this software. Now, what you got for your money was, books and discs. And actually, at the very beginning, the package was kind of pretty substantial. It wasn't just the books and discs. They also included a language card, which was a 16K RAM card. They included a couple of ROM chips for your disk controller so that you could upgrade from 13 to 16 sectors. You had a tutorial on Pascal. You had the language reference manual. You had the operating system manual, and all of this for a mere almost $500 in 1980. But I mean, you needed a pretty high spec Apple actually to be able to make use of this. You needed an Apple II or II Plus with 48K. Plus the 16K RAM card. You really needed 2 floppy disk drives. It could run on 40 columns with 1 disk drive, but it wasn't even worth it. It was so unusable. So you needed an 80 column board, and the 2 disk drives. You needed a decent monitor, and without a printer as well, you were going to have a pretty bad time. So you've already spent huge amounts of hardware, and then $500 on top. So not a major seller for Apple in the consumer market. The final version looks really different. This is actually a photo of my copy of the Pascal 1.3 Workbench. So this is 1985. They completely repackaged it. So now it's 4 5-inch floppies and 1 3.5-inch 800K floppy with all of the software duplicated onto it. A 900-page manual. Lots and lots of documentation. You can see I'm missing one of the floppy disks. I've only got 3 out of the 4, and I don't have the 3.5-inch disk either. Now this poster, this was so much fun and really iconic. A lot of people saw this hanging on walls in programmers' cubicles and in dealerships and so forth. So it's a Pascal syntax diagram. It's meant to be a ready reference. You can look up here and you can see how to define a procedure, how to define a function, what are the options for defining variables and data types and various types of executable statements. So who made this? It was really Jeff Raskin's brainchild and baby, and he poured a lot of effort into making it aesthetically attractive, and the color scheme was meaningful. He was applying, he had a color legend that meant things. Now, that's not what we're looking at today. He showed it to Steve Jobs, and Steve Jobs kind of half liked it, but he took it away and gave it to a San Francisco artist who didn't know Pascal, who made some changes to the color scheme and completely destroyed the careful color legend that Jeff Raskin had come up with. So still useful, but I always wonder what the original might have looked like. An interesting add-on was, you may have heard of a card called the Mill. It's a 6809 coprocessor. and it was way less commonly bought and used than the CPM Z80 cards. So these are practically made of unobtainium these days. They go for huge amounts on eBay. But you've got a Motorola 6809 running at 1 megahertz. It cost $369 for the system, and when it was activated, you actually were co-processing, because you had 100% of the 6809's capacity, and during some dead cycles, you were also getting 20% of the 6502's capacity. So you had a very slow, 200 kilohertz 6502 running alongside it. And one of the main uses was it was to speed up Pascal, because Pascal being an interpreted language with the P code, and also being very heavy on floppy disk access, it was kind of a dog to use, pretty slow. So the mill was able to speed up a lot of the operations, like for example, the compiling of the code was able to go much faster. And you could even run the OS9 multitasking operating system if you wanted to get really abstract. All right, now a bit about the architecture. I found a memory map, and essentially, this is your typical 64K Apple II memory map. Of course, the Pascal system is using zero page like crazy. The hardware stack, it's got some buffers for disk and screen I/O, and then you've got your text screens. Now between the text screens and the high-res graphics screens is your data heap. So this is where your variables lived. Your variables would build up from the bottom, and your program code was loaded at the top in high memory. And above your program code was the Pascal operating system, and in the RAM card itself was the interpreter. So that this was the program that those two students worked on. They wrote the native 6502 code that would sit in the language card and interpret the P codes, and all of this program code was in these emulated P codes. This book over on the right by Randy Hyde, it's called P Source, and it's a comprehensive reference of all of the P codes. I tried reading it once. I think I fell asleep about 2 minutes in. But if you want to tinker around with the internals of this system, it is available in PDF on the web, and I've actually got a hard copy of it here as well by my elbow. But very, very good in-depth technical book. There's a lot of books. There's huge numbers. It's just like Applesoft Basic in miniature. Lots of primers, lots of tutorials. Quite a lot of advanced programming books. So it was this whole parallel ecosystem to the Applesoft machine language stuff. Now, I want to talk a little bit about the features of Pascal. This will be old hat to some of you, but others may not have bumped up against it in their lives. So it's a block structured language. So you have statements nested within blocks. You can nest procedures within other procedures. You can control the scope of object names, so that you can have the local variables that Bill Atkinson was complaining about. In BASIC, every variable is global. But with Pascal, you can localize your data. You can localize your code. So that it's not visible globally across the program. And this has advantages in terms of avoiding unintentional bugs in large programs. It's got very strong data types. So it's got, integer, real, string, character. It's got a cool data type called Boolean, which can be set to either true or false. But it's really not easy at all to transfer data between these types. Pascal has very strong typing of its data. The source code is freeform, so you can make it look beautiful, or you can type it all in on one very long line. The compiler doesn't care. It's got some Apple II specific functionality for for graphics, for keyboard I/O, for paddles and joysticks. So of course, if you use any of those functions, it's not portable code anymore, but that's really irrelevant these days. It comes with an assembler. You can write assembly routines, and you can link those in with your Pascal application. And it's got this stuff called units, which are very cool. These are pre-compiled blocks of code that you can either link it to your main program, and so you can add functions that would just become part of your code file, or you can leave the unit in the system library, and it doesn't make your code file any bigger, but it will load the code at runtime from the library. So you just have to have the library file available online when you run the program. So very powerful variables. You can do dynamic memory allocation for data, really complicated and rich data structures, with arrays and records. The code is recursive, so it can call itself, which is pretty cool for a certain type of problem. Basically, do this one thing and then go and do it again for everything else, and just let it run, and hopefully not run out of stacked space. And memory management of your code space too. You can Basic can do this a little bit with like chaining and stuff, but Pascal has some pretty nifty features around swapping code in and out, and being able to manage that memory into things called segments. So you can have your initialization code in one segment, and then once that's done, it's not needed anymore. You can go to the main segment, and the initialization segment falls out, and that memory becomes available for new code or data that comes later. Just a few quick syntax comparisons to Applesoft. I just pulled a few very basic statements, a couple of print statements. In Pascal, you use the verb write, and it's not that different. In Basic, if you call HGR, you go into high-res graphics mode, screen 1. In Apple Pascal, you call a procedure called graph mode, and then to go back to text, you call a procedure called text mode. To clear the screen, you call the page procedure. You say page output. This is where it's showing its mainframe roots, because that's like chucking a form feed on a printer to get a fresh page, but you're actually getting a fresh page on your text monitor instead. It's arithmetic expressions and functions look pretty much how you'd anticipate, pretty similar to Basic in that regard. And lastly, I gave an input statement where you just input and then give a prompt, and then you give a string variable for the person to type their first name into. Now in Pascal, everything has to be declared. So I have to declare a variable called first name, and I have to give it a type of string. And then I write the prompt, and then I read the keyboard input into the string variable. So a little more verbose, but it is a structured programming language. So it is more rigorous than Basic. And this is something that helps you write correct programs, by the way. It's not a disadvantage in my mind. Flow control statements, just like Basic, you've got a for loop. For I equals 1 to 10, do something. But you don't have a next statement. Instead, you just if you've got a bunch of statements, you just put a begin and an end around those statements, and it will just loop that entire block of statements. The while loop is where you've got a logical condition. It's a top tested loop. So if you test and it's true, then it will do the loop. Otherwise, it will skip it. The repeat loop is the opposite. It's a bottom tested loop. So it always executes the statements at least once. So you repeat, you do a bunch of stuff until a certain condition becomes true, and then it drops out of the loop. So it's nice to have both types of loop available. If then else, of course, conditional statement. It's got a nice thing called a case statement. And this is, in BASIC, it's a little bit like when you say on X, go sub 1000, 2000, 3000. So it's that same idea, but it's a lot more flexible. So I'm saying if the command is S, then call shuffle deck. If the command is D, call deal cards. If the command is P, call show points. If the command is Q, call the quit procedure. Otherwise, show the help screen, because they didn't type something that was one of those 4 valid commands. Now, you do have a go to, an exit, and a halt. So they're probably only used for debugging or really extraordinary situations. You don't really want to get into those. A couple of quick examples. Very short example here, which declares a count as an integer variable, and it defines a procedure called display, where you pass it an integer parameter, and all it does is it writes out the number that you pass it. And then this is the main loop. This is the main block of the program, where you just count from 1 to 10 and you display the count. So it just loops 10 times and it calls the procedure 10 times, and the procedure prints out the number. A slightly more longer example. This one is using an array of strings, and it's declaring a couple of constant values as well as a couple of variables. And again, it has a short procedure and a for loop in the main. So I just wanted to give you a quick look at what it looks like. So why are we using it in 2025? I think it's just fun to mess around with something different. It is faster than BASIC, not that much, maybe twice as fast on average, because it is semi-compiled at least. It is a little more efficient. Like I said, there's lots of program listings, lots of books. If you want to get into it, you can spend a lot of time in there, and you can write really big programs, surprisingly sophisticated software. Now we've got, RAM and hard storage and emulators, everything like that. So the old performance problems are pretty much solved for today's users. And that's it, guys. Thank you for your attention. I'm very happy that I was able to talk to you today about Apple Pascal.
All righty. Thanks, Martin. We have probably 1 minute left for questions, and then obviously there's a few in Discord, so everybody can head over to Discord on there. So the question that I had is, can you get a remake of the Apple poster?
You may know the answer to this already. I know that Javier actually did that. I don't know if he has any stock, but
yeah,
I think I read
in the comments that he did it. I know Call Apple, Brian, and those guys over at Call Apple sell it as well. So
okay, I wasn't aware of the
comments there.
Yeah.
So
that's
right.
Good to know. I'm glad it's still available.
Yep, it's an awesome poster. So, well, thank you very much, Martin. And like I said, there's a few more questions over in Discord. If you may want to head over there and answer a few of them.
I will do that. Thank you, Jay.